Good morning. My name is Nagisa Oi from Tokyo University of Science. And today I will talk about the quality of the Subaru HSC data. Actually, in the last conference in the last year, I also presented about this HSC data, but we found that the HSC catalog has some problems. So we have tried to fix the problem, and today in this talk I will talk about the new HSC catalog information. Okay. So here is a summary of our HSC observations. So we had a total of 5 effective nights, spread it out in 2 years, 2014 and 2015. And in 2014, we had an instrumental trouble. So we could use only urban. And the seeing of the urban data is not good because of the instrumental trouble. On the other hand, in 2015 run, the weather was great. And the data quality, so we took the rest 4-band data. And the data quality is also great, much better than the urban. And we reduced the data with the HSC pipeline version 4.0.1. And this is a summary of the quality of this previous HSC catalog. And this values comes back again and again in my slide, in my talk, as the comparison.
What is the reference band for the detection? Did you combine all the images for detection, or did you use one band image for detection?
Oh, I'll explain later. Okay.
But those are only average sensitivity.
Yes.
It really depends where you are in the picture.
So signal to noise ratio is depending on the places, the patches.
Even detection limit
Yes.
depends where you are.
Yes. So, okay, then we found out the problem of the catalog. So the previous catalog is missing some sources in this kind of area like this. So yellow circle is a detection sources, and you can see that no detection in this area or like this area. And this is because of the pipeline. The pipeline version 4.0.1 cannot subtract sky well. And also degraded sources well. So, like this area damaged by the ghost of the bright star, the pipeline cannot detect any sources in this kind of area. So, this is a kind of summary of the last version HSC catalog. So, okay, we have to fix the problem. And the HSC SSB pipeline team dedicated to improve the pipeline. And now the pipeline version went up to version 6.5.3. So, okay, we just reanalyzed the same HSC data with newer version pipeline. Okay, and then this is a summary of our tricky part of our analysis. And this is a summary of the quality of the new version HSC catalog. And the reason why we had to do the tricky analysis is because not the good quality urban data disturb the source detection. Even we use the newer version HSC pipeline. So, okay, we decided not to use the urban for the source detection. But of course, we need urban data for the urban photometric data. So independently, we made another catalog, a so-called photometric catalog, which has the all potential sources. So whole potential sources include everything, every detection. It doesn't matter if it looks like a real source or fake source or garbages. We don't care about anything. we just measured every single detection area. Okay, so I will explain the point more detail. So this is the regular flow chart of the data analysis by HSC pipeline. So HSC pipeline make catalogs in each band, and then collect the position information from each catalog. And then the pipeline remove the garbages with its own algorithm to get the real sources positions, and then pipeline measure the flags at that position. Okay, this is a regular flow of the analysis, but it doesn't work well for our data if we use the urban data. This is the example. So the cyan circle is a detection place with 5 bands, and the yellow circle is detection places locations with only 4 bands, not urban data. Then you can see that if we use the urban data, then we miss some real sources. So to rescue these kind of sources, we decided not to use the urban for the source detection. Okay, so not use the urban data for the source detection. And the position information we make without the urban is called photometric position reference. Okay, and independently we make the photometric catalog, which has to have the urban information also. But as I said, if we use this urban data with the normal flow of the analysis, then we miss some sources, real sources. So this time, okay, we don't remove anything. We just include every single detection. Okay, so for example, this. I don't think these are the real sources, but we include those sources in the photometric catalog and measure the position flags. Okay, and then we combine the two catalogs. One knows only real sources position, and the other one knows the 5-band photometry. Okay, then we create the final new HSC catalog, which knows real sources with 5-band photometry. Okay? And the pipeline version 6 is much better than the version 4. So the new HSC catalog has the missing sources in the previous HSC catalog, marked in cyan circles. So okay, we can fix the missing sources problem. Okay. Then we check the quality of the new HSC catalog. Maybe not like this picture. So this is the limiting magnitude figure, and each dot is a 5 sigma limiting magnitude in each patches, different sky region. Okay. And then we calculated the average median limiting magnitude with 3 sigma clipping. So the clipped out data is marked with close mark, and then this is the result of the 5 sigma detection limit. And generally speaking, that this value is 0.5 to 1.0 magnitude deeper than the last version catalog. That is great. And this is a number count figure. The red stars means the median number count of the different the sky regions. And this gray solid line is a result from the previous study. And we can see that, okay, so our result is consistent with the previous literatures. So this is also great we talked about, the Sonjin talked about. Okay, so this catalog has all sources dictated in at least one Akari IRC band. Okay, so maybe some of the source is a fake or not real sources, but anyway, we made this catalog as an Akari NEP wide catalog and merged with the new HSC catalog with this 1.8 arcsecond starting radius, which Sonjin found out the 3 sigma of the position accuracy between these two catalogs. Then we have more than 110,000 Akari sources with HSC sources, HSC data. And the rest, 23,000 sources, Akari sources, are still remaining in Akari no HSC catalog. This number sounds larger than we expected, but some of them are just located outside of HSC coverage. So not all of them are red and optical frame sources, okay? And tomorrow, Toba-san, Yoshiki Toba, will present about his science about the red and optical frame sources started from these catalogs, okay? And then last, in the end, we split out this Akari HSC catalog into 2 catalogs. One is HSC clean catalog, and the other one is HSC flag catalog using HSC flag. The flag is a caution for photometry. For example, saturated at the center of sources or butt pixel is inside the definition of the source area. So please be careful if you use the photometry information from this catalog. Okay? But so this one may be the most useful catalog for many people. But if you're interested in the number of sources detection or matching number of matching sources between with Akari and HSC, then please use this catalog with this clean catalog. Okay, so this is a summary of my talk. Okay.
Let's get some more questions here. Could you go back to the slide that shows limiting magnitudes?
Yeah.
Not to obsess too much about this, but there are a significant number of fields which are appears to be almost 1 magnitude less deep. Maybe in previous estimates they just took an average and they said, oh, we're not really very deep. But you show, usually it's pretty deep. We have to be careful of these studying in these regions. Maybe, or what is the reason for these regions?
I didn't check which area this information is come from, which area, but so I have to check before. Then I
decide. Maybe it's on the edges.
Yeah, I guess so. Maybe this is one possibility.
Each point is a patch?
Yes, patch.
Okay.
It's a very small area, right?
Yes.
How big is the patch?
Well, there are about 100 of them, aren't there?
48 pixel versus 40 pixel.
So that means 20 arc minutes by 20 arc minutes? Something like that.
Yeah.
Oh, no. 8 arc minutes by 8 arc minutes. So I mean, it could be, if 8 by 8, there could be a bright star some in that field.
Just
then
messes it up.
Well,
It's a lot. There aren't that many bright stars, but yeah. It's sometimes.
So if I want to choose one band for the use of any, for the following studies, so probably G band is the best thing that I have to play with.
The seeing is really nice.
Seeing is nice, and the limiting magnitude is much deeper than the other band. But the well, I don't know. This is the problem. But we have the Akari data, so the probability. So the detection priority. We have to set the priority of band to make this band match catalog, and the G band is not the high priority because we are kind of focusing on matching with Akari data. But anyway, the priority of G is not that high, but we include all
Diffuse source.
diffuse source.
A lot of them.
That's the only for point source.
Yes.
So G1 is 28.6. That's very deep,
It's really deep.
isn't it?
So that's what, even if the source is red, like a car, you still probably have a better chance to identify it in G-band.
Well, it's actually.
Oh,